ideas, and this is going to definitely add to how we view mathematics teaching in the future. So we'll start with Lenin, and I'm going to ask each of you to just say a line about yourself before you start. And as I've said before, you'll have 10 minutes, and at which point we'll remind you, and then another 2 more minutes. After that, we'll keep a minute or two for discussions before moving on to the next speaker. So Lenin, we're ready to hear from you.
Yes. Hello, guys. Good morning, everyone, and welcome to the MTA conference. Very exciting thing to learn from each other. It's an opportunity where we can just share and care for the ideas we have through our experiences in the teaching and learning process. So as I'm going to reintroduce myself. My name is Lenin Kumar Gandhi, and I'm the math facilitator in Aga Khan Academy, Hyderabad. And I'm in DP because I have great passion for teaching the diploma program. So that's been my passion, because that gives me ever learning process. Every year I have the great challenge to learn many things, and that excites me to be part of the DP, IB, International Baccalaureate program. So coming to the session for today, just because we have 10 minutes, so I'm just going to look into the session. The abstract title for my session is Optimizing the Efficacy of Mathematical Laboratories. I took this as a challenge in looking into sharing my ideas, because there's a general myth in every school that we don't need a math lab. We just have science labs. That's the common understanding, or the psychological understanding of things, that labs come only with science, the subject of science. But I want to prove it false, and I want to prove on the essential needs of why a math lab when it comes to learning through realistic approaches. So that's the thing for today. So I'm just going to come into this, with the session. Okay. Now, there are different ways of learning which we introduce in the learning process. I hope you all understand what is conceptual learning, experiential learning, hands-on learning, okay, learning through research, and learning through self-analysis and learning. You know, there's a self-regulatory learning. There are various types in which we learn, right? So therefore, there is this kind of learning process also demands for something to support for the learning. And that's something which I'm calling as manipulatives or models, or whatever three-dimensional structures we're going to take to make the learning very realistic and sensible. And therefore, this session will focus more on why a math lab, what are its benefits, what is the importance of having a math lab set up along with the other labs which you have in the school in general tendency, the science labs, the art lab. So math lab is also very essential. So coming to this. Now, coming to how important is the learning through manipulatives, I'd just like to, I hope you all can see my screen. There are some models like this, you know. So if you're teaching anything related to the polygons in the class, I'm talking about the basic school level. If you're teaching about polygons in the class, then definitely learning just by the methods or the formulae would not help the student to understand the concepts more deeper. It needs something to go more beyond. Take some object in hand and try to resolve the issue. Take some strategy, put the strategy as a problem on the board, and give these manipulatives to students. And then they are supposed to use those knowledge of what they have learned about interior angles of a polygon, or it can be exterior angles, or the number of sides they can find. Anything that can be put as strategy in a real life. Now, this object will be given to the student, and the student would be just looking into researching, understanding, analyzing, and then trying to apply it in real life situation to resolve the issue. That is very important in today's world of learning. Resolving the issue, purpose of learning and resolving the issue is what makes the learning very realistic and very deeper in concepts. And that's why I think math lab is very much important, because when you have a math lab, you'll have many such ideas you can put forth, And just every year you can add many, many resources or many, many manipulatives or many, many softwares, technology, can be anything, or the web technology which you can use that can be added and set up in that particular space called MATLAB. That's why I want to put the efforts that when we share something, you should really be able to use those in one of the place which I call as MATLAB. And that is very essential. I see that is fading away. In many schools, we don't have the MATLAB because there's a general tendency, people say, it's only for science. We don't need it for math. I think it's a wrong statement. Let's prove the statement wrong. Yes. So that's the reason why I'm looking more into the math lab setup. Just to also share with one of the class which I was taking, I was taking on the pyramids. And when I was taking a class on pyramid, the students, I just gave them investigation on trying to find what could be the slant height or the middle slant height of the pyramid would be same. Generally, they feel that it's same. And then how do we prove that? We can't just draw the diagram and just analyze. Of course, algebraic approaches would be useful, but taking the model and trying to make them measure and do some experiment out there with the measurements, and then finally concluding that which one is greater, the slant height on the corner or the slant height in the middle of the face of the slant face is what they're going to research. And that's how they have learned more effectively. And that's how they have learned through realistic approach. And then they understood that, oh, this is how you can, and this is how they've been. So concepts become deeper and wider when they go into the manipulatives in learning. That's what we call as hands-on learning. So there are many types of learners in the class. Some people learn through gadgets, adaptive learning through gadgets or any instrument or any object. That's how they learn. So when you have different types of learners, kinesthetic learners, you have visualized learners. So learning through problem solving and learning through just by chart work. These are all things which we look into. But when you see most effective research, the research has proved that the most effective way of learning is through the adaptive methods. That is, adaptive learning is more powerful. And adaptive learning demands more of lab setup. And that's why my session here is more to look into what we can do through the process, and then how we can take this forward as a common voice. We just need to set up a lab and see how better it works every year. It's not just setting up, but we have to see how it is helping every year, because a math lab cannot be set up all of a sudden. It takes some time. There are some challenges, and to share some challenges, some of them are budgetary constraints. Yes, there'll be some budgetary constraints, because if you want to set up more big labs, more big models, it's quite difficult with the budget. We need to look into everything, but it's not impossible. That's what I feel. Setting up a lab, I think it's not impossible, because just doing things in a planned manner with everyone, I think would not be a big task, in my understanding. I'm pretty sure, because we already set up some models and we have a lot of things we work on. So it would be not a big deal. So I have some question here. Many schools has math labs, but we don't see any effective use of math lab. Yes, there are some schools where you have the math lab, but it's not effectively used, because the general tendency is we focus more on problem solving. We have to change the system of teaching strategies. Our unit plans should change. Our unit plans should change in a way that we give more importance to learning for purpose, learning more in realistic approach. So if you can approach, if your approaches to learning or teaching in the class is based on hands-on learning or any manipulatives used methods, definitely the math labs will become active. The many schools, this is the problem. They focus more on the textbook problems and solving on the board. And that really puts in that the math lab gets again faded away. If you really continuously use from starting, every unit plan essentially used, or lesson plan or a weekly plan, continuously set up with things where we need to essentially use the labs where the math topic being taught. If you can connect that, think for some idea. If I'm teaching mensuration, I connect to many 3D structures. If I'm using calculus, I connect this to optimization. I can literally make a model and show how optimization of a box can be done. put that in a space of container, and then show how many such boxes can fit in. So these kind of things, a lot can be done. It depends on the topic you teach. It depends on the teacher's planning, how they're going to plan according to the setup. Then the math labs really become active. And not only the math labs become active, the learning becomes very effective and enjoyable, because students enjoy adaptive learning. So it's really going to be a way in which they really enjoy the process. And that's it. This is what I wanted to say in my session. Math lab, an essential factor in the learning process, especially in the subject of mathematics, to make the concepts deeper, wider, and realistic. Okay, guys, any questions, please?
There is a question from Siddharaj. Math school teachers complain lack of classroom time. Can you suggest ways of integrating experimentation within the existing framework?
See, lack of classroom time comes only when the teacher comes with a tendency that math teaching of the syllabus is different and going to the lab and learning is different. It's not different. It is combined. In the process of learning, you're going to introduce a math lab activity with the students. It should be within the lesson plan of the week. That's what I feel. So lack of time would not be there if you smartly just combine or the learning in the process of learning, you include the modules and then try to take the students to the lab and introduce a model and then explain the same concept to the model instead of explaining separately on the board and then again separately taking to the lab is lack of time. That's a smart way you need to deal.
In fact, that's something that Pankaj Ranjan has also said, which is that don't think of the maths lab as a separate room to which you have to take the students to. I guess what he means is that bring the maths lab into your classroom and so make the mathematics classroom itself a maths lab in that sense. I think that seems to be, Pankaj, have I sort of paraphrased what you're saying correctly?
Yeah. Yes, ma'am, you have rightly said about me and my concept. We may move to our classroom with teaching aid and students some willingly will participate in those classes.
So
it's always good. Yes, I really like that. Making your own classroom as a math lab would be very effective and that thing. But there are some challenges because in some schools classes happen in different rooms. So
So
and then setting up conflicts lab would be quite challenging.
Yeah, but maybe keeping. So identifying, since the rooms are going to be used in any case, maybe identifying one room or two where these things can happen might work better than, because it's also being used as a classroom to teach. Otherwise, if you have a lab space, others can't tend to use it. Right? So that's the thing. Siddharaj has a comment to make, and
so when I said the existing framework, I did not the spatial thing did not occur to me. The place I'm coming from is that a typical classroom is of 35 minutes in a school, right? Given the timetable constraints, you can't really club periods together. We're facing this difficulty, and typically an experiment requires a longer sort of activity and time for the students to think. I wanted suggestions in that regard. Can we if there is something that has been tried and tested somewhere, because we are looking to integrate this into Goan schools somewhere, but we're facing a difficulty in terms of time constraints, not spatial constraints.
Siddharaj, yesterday
I have a question.
We had a very good session yesterday on math lab and the kinds of activities.
Oh yes, I missed that. I will watch the recording.
It will be available on YouTube, so you should.
Yeah. I've seen the link.
And maybe Jam can say something about what Azim Premji has been doing on it very quickly before we move to the next speaker.
No, I think it's better to watch that video because it's a more comprehensive one to look at rather than my one.
But have they also thought about how to integrate it into the classroom? Is there any on that?
Yeah, there is. I mean, that's at undergraduate level. undergraduate level, it's integrated into the classroom.
To the classroom through courses and,
Yeah, because there is no...
they have these clubs as well and so on.
At undergraduate level, the time span is also more, right? Like
longer. Yes. Yeah. So, but I think we will run out of time. So I'll go to move to the next speaker. Archana and Mamta, are you ready?
Yes, ma'am.
So please say a line or two about yourself and then please get started.
Yes. Yeah. Yeah. Good afternoon. Good morning, all of you. Myself, Mamta, my colleague, Archana. Yeah, we are from School of Scholars, Yavatmal, Maharashtra. We are teachers from, we are teaching class 9 and 10 grade. And we are putting forward our experiences, classroom experiences in front of you all. Good morning, all of you. Topic, CT integration in mathematical practices under the theme mathematics and computational thinking.
Mathematical thinking and computational thinking. We know that these both are types of problem solving approach. How we apply mathematical thinking or how we think mathematics. So
Archana, can you be a little louder? We can't hear you very well. So can you be a little bit louder?
Yes, ma'am. Okay. Shall I, ma'am?
Yeah. Go ahead.
So we are talking about mathematical thinking and computational thinking. So mathematical thinking and computational thinking are both types of problem solving approach. How do we think mathematically? For that, these steps are involved. First of all, we are understanding the given problem content. Then we organize problem information. Then we coming up with and execute our plan. And after that, getting result, we are verifying that. So for example, if we consider a word problem. So here it is given the word problem which I consider. That is, there are 42,306 trees in a forest.
Archana, is your slide also supposed to move or?
Yes. Mamta, please. Mamta, next slide, please. Hello, Mamta.
Mamta, can you hear Archana?
Hello.
I think maybe her network is not.
Yeah. Hello, Mamta.
Yes.
Please.
Okay.
Am I audible?
Yeah. Now you're.
Yeah. Is my presentation visible?
Yes, it is.
Okay, ma'am. Actually, it's raining heavily. That's fine.
So here we consider one word problem. That is, there are 42,306 trees in a forest. Of these, 23,479 are teak trees and 16,675 are subabul trees. How many other trees are there in the forest? When students are solving such type of example, so how they think? First, they read the question carefully, and then they are thinking about what it is given in the example. Then next, they are finding what it is asked in the example. Then they think about which operation we have to apply here. And then by applying that operation, we come up with the result. These all the process we use in mathematics thinking. Next slide, Mamta ma'am.
Yeah. Let's computational thinking. Computational thinking is involved in formulating a problem and expressing its solution in such a way that a computer, human, or machine can effectively carry out. There are concepts of computational thinking, that is decomposition, pattern recognition, abstraction, and algorithm. Decomposition means breaking down the problem or data in smaller parts. Pattern recognition, observe and abstraction. So we had a talk about. So do we use does it matter?
Mamta, your voice is breaking up. I think the connectivity for you is a bit of a problem.
Yeah.
Maybe if you switch off your video, it might be better.
Okay, ma'am.
In fact, I think let us all switch off our videos so that.
Yeah. Am I audible, ma'am, now?
We can hear you.
Yeah. So does it matter that these were the trees in a forest? What if the problem was the following instead? There were 35,876 cars sold in Pune last year. Of these, 17,234 were Maruti cars and 10,675 were Hyundai cars. How many other cars were sold last year in Pune? So previous problem, we solved it by using mathematical thinking. And this problem, so students will use the similar solution for solving the another problem. And here the students are using the city skill, that is abstraction. Over to you, Archana.
Most of the developed countries included computational thinking in their curriculum to enhance students' thinking ability. So our media group of schools always take such initiative which helps students to develop their thinking ability and has integrated PT in our curriculum from 2008. Our paper states about the activity where students of grade 9 use PT skills in BMI project and lab activities, where students use different skills of computational thinking like pattern recognition, information processing, data analysis, and algorithm.
Nowadays, increase in weight is a big issue. Therefore, on the occasion of Yoga Day, students were given a project to find how many parents and students of class 9 are under the categories of underweight, healthy weight, overweight, or obese. To create awareness about healthy weight among all the students and parents. Students came up with the algorithm to find BMI of their parents as well as themselves, and they categorize it in the given categories, that is underweight, healthy weight, overweight, or obese. Here are some evidences of the students' work. Students' projects we are showing here. Then data was collected for 80 students by using frequency distribution table. Student use CT skill pattern by analyzing data for number of father, mother, and students fall in which category, that is underweight, are they healthy, or they are overweight, or they are obese, and depicted these information by using bar graph. Also, they find out the appropriate yoga to overcome the problem. Over to you, Archana.
In lab activities too, yes, we can see here one of the lab activity of class 9, which is to obtain mirror image of a geometrical figure with respect to x and y. So here we ask students to plot the given points in Cartesian. After plotting points, students locate their observation in observation. And here you can see the observation of the students. Students identified here that they identified the pattern that the image of any point along the x-axis, x coordinate, it remains same and the sign of y coordinate change. The same way, the image of any point along y-axis when we observe, so y coordinate remains same and the sign of x coordinate changes. So from this, through this pattern recognition, students understand that, or they can tell mirror image of any point or any geometrical figure with respect to x and y axis without plotting that point. This involves pattern recognition skill of computational thinking.
In another activity of 5 by 5 and 6 of Jodo, square was made up of Jodo blocks, and it was asked students to express the given square in the form of identity a plus b whole square. So here student make the combinations of square of 5, like they have taken the combination 4 1 2 3 to express the square of 5, and 4 2 5 1 3 3 to express the square of 6 in the form of identity a plus b whole square. So here students use decomposition and systematic listing and counting, which is the one of the CT skill.
Mamta and Archana, you have to wrap up in 2 minutes.
Yes, ma'am.
Yeah, ma'am. Integrate systematics. Students are implementing computational thinking skills in their curricular activities. Computational students to be active learners rather than passive. Computational thinking encourages children to scrutinize a problem and build a solution for it. Mathematical thinking is limited to mathematical problem solving, is being more broadly applied to complex processes and relationship in
Thank you, Mamta and Archana. Any questions or comments that people have?
Yeah, just a minute.
I mean, I wanted to say something on this. I mean, differentiating between mathematical thinking and computational thinking in a way, I mean, to me, I think without knowing these technical terms, mathematical thinking encompasses computational thinking in the sense that if you're able to analyze and model problems, that I think I tend to think of that as a mathematical way of thinking. But it's interesting that there are these different ways of learning that seem to have emerged in this through this, from when I've been listening to people. So there's critical thinking, there's computational thinking, there's mathematical thinking, and sometimes I think all of these do overlap as well. That's the sense I seem to be getting, unless I'm mistaken. So, any comments and queries that anyone else wants to make? Otherwise, we'll move on to the next speaker. So, is Arzu here? Archana, Mamta, can you stop sharing your screen?
Yes, ma'am.
Thank you, Mamta. Thank you, Archana.
Thank you, ma'am.
So do we have Arzu? I think Arzu is not there. Is that right, Saurabh?
Yes, ma'am. Arzu hasn't reported so far. So let us move to the next one. And if
Yeah.
we
Is
find
this
time
Arezo? Is this Arezo or Arzu?
Arezu.
Arzu.
Arezo is from Afghanistan. I've been trying to get to touch with her. She's not connecting. Okay, go ahead, please.
So Ruchi, anytime that she connects, she can, join in and then present.
Yeah, she must be having some network problem and there can be other issues also. I'll try to connect with her and get her to present.
Sure, sure. So after Arezo, we have Vinay. So Vinay is going to speak on exploring computational thinking in the mathematics classroom. So
can I start?
yes, please.
Okay. Hello everyone. Yeah, my name is Vinay Nair. I'm a research scholar at Chinya Vishwavidyapeeth. I have been into math education and in this space since about 14-15 years. And I work in an NGO called Raising a Mathematician Foundation, where we work with students and teachers, giving them a bigger, broader picture of mathematics beyond the school curriculum. So having said that, I'll move on to the presentation. So in this paper, what I've tried to do is try to take tasks that we can take into the math classrooms that help develop mathematical thinking as well as computational thinking. So I've taken 4 problems and try to dissect them and see what aspects of CT and MT come over there. The definition of computational thinking has just been discussed in the earlier presentation. So that's the same definition that I'm going to follow in this presentation. About mathematical thinking, well, there are different definitions. So like Snyder says, application of mathematical ideas and concepts in solving problems. So if you go by that, then if we take a Venn diagram of CT and MT, it may come to something like this, where we have the topics of mathematics and computer science that come as subsets of mathematical thinking and computational thinking. But that's not the kind of definition that I'm referring to over here. It is more broad, like Keith Levelin's definition, like a specific way of thinking that includes logic, reasoning, and analytical thinking. And I like Burton's definition even more because it lists down all the processes that are involved in thinking, like ordering, organizing, categorizing, enumeration, substitution, study of relationships, manipulation, making correspondences, and performing operations, and so on, for helping us achieve 4 processes: that is specializing, generalizing, forming conjectures, and coming up with proofs to support or disprove the conjecture. So this is the definition of mathematical thinking that I'm referring to in this presentation. And before we go into the 4 problems, there is 4 facets of computational thinking that the earlier speakers also talked about. So I'll not explain each one of them here just in the interest of time. And we'll move on to these 4 problems that I tried doing with groups of students of 10 to 14 years of age. So let's start with the first one. This is Pinocchio's classmate. So in this problem, Pinocchio is a character who can convert a student into a truth teller or a liar. So what happens is Pinocchio comes to the class and does this, conversion business. And then the truth tellers will raise their hand only if they are sitting next to exactly 2 truth tellers. Liars will raise their hand only if they are not sitting exactly next to 2 liars. So this is the scenario given, and we have a 2 by 2 grid where 2 students raise hand and 2 of them don't. given this scenario, can we determine which of these students, each cell is a student, which of these students are truth tellers and liars? So eventually students figured out who are the liars and who are the truth tellers. They started with the if then else kind of condition, and they went ahead and found out who are the truth tellers and liars. So the next question that followed was a slightly different variation, that these two have raised hands and these two have not. And can we determine who are the truth tellers and liars? And to the students' surprise, they found that there were not one, but 5 solutions to this particular problem. And some of these solutions were having rotational symmetry, which probed them to think, why is it that the rotational symmetry is working here? And eventually they figured out that if you rotate this particular problem by 180 degrees, it comes to the same problem. So a solution when rotated 180 degrees should give you another valid solution to this problem. So they used these ideas and solved a few 2x2 grid problems before we moved on to a 3x3 grid problem. And again, some of them started with a corner piece or a central piece and used if then else, that if this is a truth teller, then what's the logical consequence? Or if this is a liar, what's the logical consequence? But interestingly, a few students, what they did was they did decomposition, and they used the knowledge that they knew about 2x2 grids, and they said, well, I'm going to attack this part of the problem because I know what's the solution to that. And that way they broke the problem into 4 2x2 grids. And there are 5 different possible solutions for this particular arrangement that we just saw in the earlier problem. And they did for each of these 2x2 grids. And there were some logical inconsistencies, which they eventually, ruled out. And they figured out that there were 4 valid solutions to this problem, and 1 was rejected. And this problem was again extended, that if everybody in the class raise their hand, is there a way we can find out who are the truth tellers and who are the liars? And can we generalize it for an n by n grid? And they enjoyed solving these problems. So these were some of the solutions that I've taken a screenshot of. They found 2 solutions for a 4x4 grid, 2 for a 6x6 grid, 1 for a 5x5, and they went ahead for 7x7, 8x8, 9x9, 10x10. This was something like, I don't know, maybe 21x21. I remember they saying they found a way to do 3 mod 4, and they had done for other remainders also when divided by 4. And how they came up with these solutions was that they saw that in all the solutions, the truth tellers were forming an unbroken chain along the boundary, and the liars, if they existed on the boundary, they were just 2 of them next to each other or 1 next to each other. So these were bits and pieces that they joined, and they tried solving for bigger grids. Now, let's look at what aspects of CT is getting covered here. So clearly decomposition is getting covered, and pattern recognition, of course, and abstraction also. They converted the problem into some suitable ticks and crosses, and they came up with algorithms in using which we can solve these problems. Now, when it comes to mathematical thinking, again, when we look at all these aspects of mathematical thinking that Burton was talking about, that is substitution, enumeration, ordering, organizing, studying relationships, each one of these is getting covered when they are solving this problem. Okay, then we move on to the next problem, that is a greedy pickle monster problem. This problem is such that there are n number of jars, and every jar has certain number of pickles, such that the ith jar will have I number of pickles, and the greedy pickle monster wants to have as many pickles as possible and finish all the pickles in the least number of days. And what it does is it will pick a certain number every day, and it will take that many number of pickles from all the jars possible. So can we find out a strategy using which the pickle monster can finish the pickles in least number of days? So to give an example, if there are 7 pickles, then if the pickle monster chooses 7 pickles on the first day, then it can eat only 7. But if it chooses 6, then it can take 6 from the 6th jar and 6 from the 7th jar. So it can eat 12 on the first day. And similarly, if you take 4 pickles on the first day, then it can eat 16 on the first day, and 2 on the second day, and 1 on the, so is using 4, 2, and 1, it can finish all the pickles in just 3 days. But if you start with 5 pickles, it's going to take 4 days to solve it. So 4 days to finish the pickles. So what they were trying to do is they were trying to find out for different values. They did it for 8, they did it for 6, and eventually they found a table and tried to find some kind of a relationship between the number of jars and the number of days it takes to finish the pickles. And this is what they found out. came up with two strategies to solve the problem. So one of them was taking powers of 2. That is, if there are n number of jars, then we need to take 2 power x, such that 2 power x is the closest power closest power of 2 less than n, and you take that many number of pickles on the first day, and the next day you take 2 power x minus 1 number of pickles, the third day you take 2 power x minus 2, and so on. So in x plus 1 number of days you can finish all the pickles. So this was one algorithm that they came up with. Another algorithm was a greedy algorithm, and none of them except one knew about greedy algorithm, but they figured out while they were solving this. So what they said was, let's not worry about whether we'll be able to finish the pickles in the least number of days. Let's just try to think what number should I choose so that I'll get the maximum number of pickles for a particular day. And that ended up being a greedy algorithm, and it really worked. So these were a couple of algorithms that they came up with to solve the problem. And again, all the aspects of CT was getting covered while they were solving the problem. And similarly for mathematical thinking also, all these aspects were getting covered when they were solving the problem. Couple of more problems, Pythagorean triplets, as we all aware what they are. These three expressions help generate Pythagorean triplets. So the question was, can we find out the values of m and n given a Pythagorean triplet is generated using these expressions? So can we do some backworking? So what they did was they listed, a lot of Pythagorean triplets, and then they tried to find some patterns in them and categorize them as per the patterns. And then whenever they would get a Pythagorean triplet, they would see which category does it belong to. For instance, if you have a triplet where the difference between the last two numbers is 2, then it comes to this category, and this is the category where n is equal to 1, and that's how they will find out the value for m. So that way, based on patterns, they were attacking a lot of problems. And some of them came up with algebraic ways to attack the problems. Like if you have a triplet with exactly one even number, then it has to be 2mn, and then you factorize that, and with a bit of trial and error, you can find the value of m and n, or use algebraic identities and linear equations in two variables and solve that and get the solution. So here again, we see all the four aspects of CT and all the aspects of MT that Burton was talking about getting covered here. We move on to the last problem, the magic triangle problem, which I borrowed from at right angles. So here, if you arrange the numbers from 1 to 6 in such a way that the sum of the numbers on every edge is the same. So can we do that? And naturally, they all tried with trial and error initially, only to see that their neighbors or their friends have got a different solution. So they were motivated to find how many solutions exist, and is there a way in which we can find all possible solutions. And they started comparing each other's solutions, and they saw that if you take one solution and take its complement from 7, you get another valid solution. And they also thought, is there a way in which we can find what numbers will go into the corners using elementary algebra? Or, can we get an upper bound and lower bound for the total for each row? And then they found that there were 4 solutions to that, and they wanted to explore the next level of order 4, to which they took some time, and they found that there were 18 solutions. They were quite excited that they came up with an algorithm with which they could attack, and naturally they wanted to go one step further, solve it for n equals 5. But when they were doing n equals 5, they got very frustrated because the number of solutions were too many, and they said that there is no way that we can list all of them down. So one of them volunteered to write a code in Java, a 7th grader, and he wrote, and the code, of course, it took him more than 2 to 3 weeks to improvise the code. And then he found out that for order 5, there were 700 solutions, and for order 6, there were 13,123, and so on. So, for order 10, it was 4.2 billion solutions. And this was like a aha moment for all of them, that they started with this and, math problem, and they went ahead and did it. So again, all the aspects of CT and MT are getting covered. I'll move on to the last part. Geetha, I just aware of time. So if you look at what concepts in mathematics are getting covered in these problems, one may say in the first 2 problems of Pinocchio's Playmates and Greedy Pickle Monster, there are hardly any problems, math concepts that are getting covered here. But if you look at mathematical thinking as per Burton's definition, then I think it is these 2 problems are definitely good problems to develop mathematical thinking as well as computational thinking. And when I look at these facets from computational thinking, like pattern recognition, for instance, I feel these aspects of mathematical thinking are based on pattern recognition. You cannot do ordering, organizing, categorizing unless and until you have the ability to recognize a pattern. And for manipulation and performing operations, we need to have the ability to use or develop algorithms. And similarly for abstraction, you need these things. So I found, for me, I mean, my conclusion when I tried to look at CT and MT in these problems was that CT was more like a subset of MT. Of course, depending on what you define as MT, and I'm going by Burton's definition. And this is what I found, and I'm happy to hear your comments, questions, any on this. And this is my email ID. I'll be happy to get your questions or comments on this. Thank you so much for this opportunity.
So any questions or comments that anyone has? Vinay, these were done with a set of students outside of the classroom, is it?
That's correct.
I mean, to me, what it seems like is that something like this should also enter the classroom or school space.
Absolutely.
And maybe Siddharaj can start thinking about how to integrate this kind of thing within schools, because I mean the fun in mathematics classroom somehow needs to come back. And I mean I think the conundrum is that how do we manage teaching the mathematical concepts which we think that a student needs to know during their school period with the fun in mathematical thinking, which stays with you for the rest of your life, really. So yeah, so maybe if we have time in the end, that is if Arezo doesn't join us, we will. But I think let's move on to the next presentation. And we have Tejaswini, who's going to talk about curricular knowledge of the teachers and its effect on pedagogy and assessment practices. So Tejaswini, please go ahead.
Yes. So hello everyone. I'm Tejaswini. I'm a research associate in Tata Institute of Social Sciences, Mumbai. So I'm going to present about findings, which is mainly based on my MA thesis with the guidance of Dr. Ruchi Kumar. So my main thesis was about examining the coherence between intended, implemented, and assessed curriculum upper primary mathematics. So there the focus of my study was topics related to proportional reasoning. So as it forms the basis of many like landmark topics like fractions, ratios, proportions in the upper primary curriculum. And also researchers has found that instruction play a prominent role in developing this proportional reasoning. And we all know that NCF 2005, which had brought a paradigm shift and also revamping of curriculum and textbooks, and the subsequent position paper on teaching of mathematics also called for shift from mechanical procedure to developing ability of mathematization. So here I am trying to examine the teacher's knowledge of the curriculum related to the topics involving proportional reasoning and how this knowledge is affecting their pedagogy and assessment practices. So when we look at the literature, we find Schulman's different knowledge bases, and he has noted that curricular knowledge is one of the important categories of content knowledge. So here the curricular knowledge includes awareness of various instructional materials, teaching procedures, learning objectives. It also includes knowledge of alternative curricular materials available and also knowledge of curricular materials in other subjects, and also that which has taught in the same such subject during preceding or the later years in the school. So from here I come to my research question. So as I said earlier, my actual study has questions seeking exploration of coherence between intended, implemented and assessed curriculum. And the sub-questions involved examination of various curricular documents, assessment documents and teachers' knowledge and perception about the curriculum. So these questions have led to the exploration of curricular choices, knowledge of teachers with respect to proportional reasoning and its effect on pedagogy and assessment practices. So when it comes to the framework of analysis, so as proportional reasoning involves reasoning multiplicatively within and across quantities, mathematical process skills which are mentioned in NCF position paper, it helps in developing mathematical reasoning which include proportional reasoning as well. So once this NCF document was analyzed, these process skills such as formal problem solving, representation, reasoning were identified, and further these were used as a basis for analyzing classrooms, interviews and assessments. So when it comes to the research design and methodology, qualitative research approach was used, and the 2 government schools and 2 private schools were used, where 3 were using state curriculum, but which was exact adaptation of NCERT curriculum, and 1 followed NCERT curriculum. So as a first step, curricular document analysis was done, and after that classroom observation was done, which was about of 6th class topic, equivalent fractions, ratio and proportions, and observation was made of 4 maths teachers with 2 classes per teacher, so total 8 classes, and later semi-structured interview was taken. Here 5 mathematics teachers interviews were taken, and as the assessment analysis, question papers, slip tests and also formative assessment were used. So here I give a brief background of the teachers. So here you can observe that 2 of the teachers who were maths teachers had a non-mathematic background, that they didn't in their graduations and even in the B.Ed they did the humanity and language. So coming to the findings and analysis, while analyzing the curricular documents from NCF 2005 and position paper, so 3 important, as I mentioned earlier, important process skills along with the child-centric and context-based learning mentioned in the NCF document were derived, and these were based as the analysis for other documents. So when looking at the syllabus, there were some general suggestions like space for reasoning and multiple correct answers, but no specific instructions for each concepts. Similarly, learning outcomes did not specify the development of any particular process skills or the development of concepts with the aid of process skills. So coming to the chapter analysis, so we can see that in all the chapters, the questions were majorly direct-ended questions, and many numerical problems could be found. So for example, like find 2 more equivalent ratios for the given ratio, or find the missing number and the numbers are given. And in a word problems, the questions were like, what is the ratio between number of girls and number of boys if the number of girls is this much and number of boys is this much, like that. So therefore there is a little scope for open-ended questions and also multiplicity of representations or reasoning skills. Thus here we see that there is a misalignment with what was intended by the document, NCF document, and what is there in the textbooks, which are called as potentially implemented curriculum. So next, when we come to the analysis of classroom practices and teachers interview, so here it unpacks teachers' knowledge, beliefs and perception about the curriculum. So while looking at how teachers introduced and explained the concept, we find 2 distinct practices by teachers. Like for example, 3 of the teachers, they used single method and the closed-ended direct explanations were used. and focus was mostly on procedures, and they believed that reasoning is uh, is explaining of techniques. On the other hand, two of the teachers classrooms were involved open-ended questions, and focus was more on conceptual understanding. They used the opportunity was given for multiple reasoning. They have also used an online platform called Matific, which had a opportunity to for having multiple solutions. So to give an example, one of the teachers, how the teachers classroom looked like. In case of the teachers who focused on procedural understanding, the introduction of the topic ratio was given by writing a number of girls is to number of boys is equal to 13 is to 16, and she explained that here we are comparing the number of girls to number of boys, so this comparison is nothing but ratio. So we write 13 is to 16 as the 13 by 16. So the when we write 13 is to 16, that becomes ratio. Similarly, she gave another example like 30 is to 20 and wrote it in a fraction form and simplified it. And this was continued further in class. So when we come to the introduction of topic of ratio by teacher N, who focused on conceptual understanding, she first started with the words asking. It was more of the interactive class, and where she was continuously probing the students, and she started with asking students to collect all the words related to comparison. So she started by unpacking the word comparison, and from there they slowly moved into the fast, slow, then who writes fast, slow, and writing in 15 minutes versus 20 minutes. There the comparison was done in additive terms, and from there the other few more examples of additive comparison was given. Later they came to the examples with multiplicative terms. So slowly from there she defined the ratio. So this was the major difference which was observed when textbook had briefly introduced additive comparison by additive terms, then moved on to multiplicative terms. So in the practice, in the both the teachers practice, we can see this major difference. And similarly, we can find the other examples where here mostly the teachers believed that knowing multiplication table is important, and solving problem is more important than explaining. And on the other hand, we can also see students coming up with 3y is to 2r, and also coming with cooking activities for explaining how many times. So, but when it comes to the materials used, the textbook was the main reference materials. Even though the two teachers used other sources like Matifics and also used the vertical knowledge, like they used the previous year textbooks for knowing the previous knowledge of the students and also building the knowledge from there. But when it comes to solving the textbook exercise, all the teachers focused on the procedures. For example, the teachers who otherwise focused on conceptual understanding while solving the exercises, she was we can see her telling how to simplify using various procedures, like asking students to say, tell the steps. And here we can see students saying we use multiplication table, both tables, both we will see in which multiplication tables both the numbers in numerator and denominator arise, exam, etc. So so here we can see that the textbook forms the main basis of their teaching learning practice, and somewhere it has the influence on their pedagogy. When we look at the assessment, although the formative assessment,
we just need to wrap up in a minute or so.
Yes, ma'am. So when we look at the written tests, all the teachers was mainly focused on the procedural, as the examples are given here. So either all the questions were related to the were exactly from the textbooks or similar to the textbooks, and also from the interview we can see that they are saying mostly they take from the textbook or by changing the numbers. So in conclusion, we can say that we find the deviation in curricular goals of NCF documents and what is given in the textbooks. So all teachers relied on textbook, and even when few teachers stressed on conceptual understanding, solving exercise problems involve procedures. And also assessed questions were closely linked to the textbooks. But when we look at the practice of those teachers who has knowledge of alternative materials and vertical knowledge, it had an influence on their teaching. For example, as I mentioned about the use of mathematics. And also there is one more observation is that the teacher's knowledge is also linked to their initial teacher education. For example, teachers who followed traditional approach had no training in mathematics pedagogy. So therefore, we can say as a final comment, we can say that the textbooks have direct correlation with teachers' knowledge and practice, and thus the influencing pedagogy and assessment practices of the teachers. So these are the references. Thank you.
Thank you, Tejaswini. I was also wondering, the two teachers who did not have a maths background at all, were they the ones who also went for the more traditional approach of just explaining a definition and then doing the problems?
Yes, exactly. So they did it either out of interest and or due to the lack of faculty. And when asked, they said that they were able to do it because based on their student experience. So how their teachers taught them, based on that, they were teaching their students.
Right. The other question is that when the students were assessed, did the approach that the teachers take make a difference to how the students have learned? Because I mean, you did mention that the questions in the textbooks were more direct. They weren't really testing many of the things that were mentioned in the NCF document. So when it came to even with these different approaches that the teachers took, how would you figure out whether it has had its intended consequence? Because we assume that if they've gone into a more deeper conceptual understanding of personality by taking them through experiences and building up on their knowledge, then the students would be able to tackle that more robustly. So is there something in your findings that supports it?
Yes, one of the teacher who actually followed this, whose practice was more aligned to the NCF document, she said that she had find in the answers of the students, not just the one method of answering it, but multiple ways. They use their own methods of answering the particular students particular solution, even when she never mentioned about that method. Yeah. So I think somewhere although she
internalized by the students.
Yes.
Thank you so much, Tejaswini. Sorry, I took up the question things because I wanted to ask. But we have Vinita next and Narendra. And they are going to present about exploring gamified flipped classrooms in learning perimeter and area. So, Vinita?
Yes. Can you see my slide, ma'am?
Yeah, we can see.
Thank you. Good morning, everyone. It's a pleasure and honor to share our research work titled Exploring Gamified Flipped Classroom, Learning Perimeter and Area. I'm Vinita Shrote, Research Scholar, SMDT University, Mumbai, India. I have experience of teaching as an educator and as a teacher also at secondary level schools. My co-author is Narendra T. Deshmukh, working at Homi Bhabha Center for Science Education, TIFR, Mumbai, India. This slide shows the outline of the study which we are going to be discussed. Post-COVID-19 education gave us the opportunity to reimagine classroom instruction using technology for effective teaching. Though Indian classrooms are unequipped with the technologies, teachers still can use them as an out-of-class activity. The good practices during and before the pandemic can be replicated in the form of blended learning. Various studies shows the students incorrectly assume that perimeter and area are directly correlated and that one specifically determines the other. One other study shows elementary and middle school students often fail to distinguish area from the perimeter as different attributes of 2D shapes. Some of the misconceptions which the students came with in the classrooms are: the students incorrectly assume that the perimeter and area are directly correlated and that one specifically determines the other. Elementary and middle school students often fail to distinguish area from perimeter as different attributes of 2D shapes. The slide shows various studies shows efficiency of using the flipped classroom in the physical classrooms also, but challenges of using those flipped classroom exist, such as lack of motivation for in-class preparedness is there. Rather, when flipped classroom is supplemented with the gamification, what we get is gamified flipped classroom. It shows that gamified flipped classroom strategy enhances students' performances and engages the students, as the recent study was conducted in 2022. Students remain prepared before in-class activity. Various researchers has been found that. For this, we have framed two research questions as how students performs in classroom with gamified flipped and non-gamified flipped instructions on the achievement. And the second one is how they perform on the interest. The two null hypotheses which were framed as: there is no significant difference between the adjusted mean scores of achievement of gamified flipped and non-gamified flipped group by considering pre-achievement as a covariant. And the second one is there is no significant difference between the adjusted mean scores of interest of gamified flipped and non-gamified flipped group by considering pre-interest as a covariant. Here's the research design. The study investigated the effect of gamification tools at puzzle and 99 math on achievement and interest of students in learning perimeter and area using quasi-experimental design, containing 82 students from Standard 6 from Maharashtra State Board using a purposive sampling technique. Data was collected using the achievement test, and data on the interest was collected using mathematics interest inventory by Stevens and Olivers. The data was analyzed using ANCOVA. The various tools, gamification tools used in the study are at Puzzle. This it is a gamification tool, and it's also it is used for flipping the classroom and also as a formative assessment. The second tool which we used is 99math.com. It is used for giving the practice to the students in a fun way. Here's the screen shows the study uses interest-driven creator theory, which hypothesizes that knowledge can be created by engaging students with support of technology. It consists of 3 loops. The first is interest loop, which denotes activities for provoking interest. We use gamifying tools for creating interest in the students. In the beginning, For each subtopic, researcher gave the link of an online assignment consisting of questions of low difficulty level, which were based on students' prior knowledge. Thus, students from all the categories, that is low, middle, and high achievers, got challenged with crossing every difficulty levels. And by chasing the peers on the leaderboard, also invoke their interest. Thus, the study by Pong and others shows the same, thus providing optimum levels of challenging tasks, help in sustaining student interest. And the next is the creation loop, which is related to the problem solving. We gave the initial content in order to prepare for the next class as out-of-class activity to both the groups. During the combining phase, students enrich their learning by combining in-class and out-of-class activity. One of the researchers as a mentor explained each subtopic and asked to solve the few problems as in-class activity. Thus, the students got the practice of combining previous knowledge with the new one. In staging, students solve problems and show their work for the gamified group. The imitating component is also driven by various gamification tools where the students got practice on their learning content. Next is the habit loop. It is related with the habit. We try to inculcate the habit of doing homework. We give practice on solving the problems using 99 math to the gamified group and shared worksheets with the non-gamified group. The slide shows how we implemented the program. For giving the hands-on practice on gamifying tools, 2 separate online introductory sessions were conducted on the Zoom platform. Researchers asked students to download the Edpuzzle app and gave the class codes. After that, the intervention program consisted of 10 face-to-face classes of 35 minutes each for both the groups separately. For flipping the class, the same Edpuzzle videos were shared to both the groups. But the difference was that the videos of Gamified Flip group were embedded with 5 to 8 questions of 100 marks each. The slide shows the result of analysis using ANCOVA. It shows that adjusted F value for achievement and interest is significant at 0.05 level with DF is equal to 1/79. It indicates that there is no significant difference in the adjusted mean scores of achievement and interest of gamified flipped and non-gamified group. Thus, both the null hypotheses were rejected. Hence, the findings of the study shows preparedness of the students of gamified flipped classroom for in-class activity. During in-class, we observed they were participating in discussion, giving answers, asking questions, showing better performance in the surprise test, which shows their increased interest. Preparedness of students shows flipping the classroom with online gamification tool Edpuzzle mitigates the challenge of unpreparedness of students for in-class activity. The researchers also found the Edpuzzle as a formative assessment tool. As teachers gets the report about quiz responses, level of completion of assignments, scores, and the total time spent on each video, which help to plan the upcoming lesson. The Edpuzzle report for the non-gamified flipped classroom shows whether the students watch the video and the level of completion of assignment. 99 Math made the concept of perimeter and area interesting. Study shows it can be used for giving the practice of solving mathematical problems. It helps students to increase speed and accuracy to reach the highest position on the leaderboard. The report on 99 Math shows scores, mistakes, the time taken for the fastest and slow answers, and the number of times students had played the game. It helps teachers to understand which concepts or problems are difficult to understand and solve. The researchers observed the students of non-gamified flipped classroom were not prepared during in-class activities as most of the students were unable to give the answers. Comparing with the gamified flipped classroom group, the non-gamified flipped classroom group performed less on achievement and interest. Unpreparedness may be due to the Edpuzzle videos were not gamified and the worksheet did not evoke their interest for doing the homework. Our study concludes Gamification as an out-of-class activity in flipped classroom settings offer better achievement of and fosters interest in perimeter area as students got practice. Students in the gamified flipped classroom show preparedness for in-class activities, work at their own pace with speed and accuracy, and have better learning experiences as compared with non-gamified flipped classroom. At present, and 99 math can be used as a formative gamification tool. Moreover, Edpuzzle can be used for prepping the class, and 99 math for giving the practice for solving the problems in mathematics. This gamification promotes fun learning, and leaderboards help students to engage results in better performance. Thus, based on our study findings, we would like to suggest post-COVID blended learning in the form of gamified flipped classroom strategy can be one of the ways for the new normal. The authors would like to recognize the support of the students of Srima Gayatri English Medium School for their participation and cooperation. Special thanks to the chairman of the school, Dr. Nivedita Deshmukh, for giving the permission to conduct this research. Dr. Narendra Reddy Deshmukh acknowledges the support of the Government of India Department of Atomic Energy under the project identification number RTI 4001. Here is the list of some of the references which we have used for the study. Thank you so much.
Thank you, Vinita. Any questions, comments that people have? Lenin has said that he's used Edpuzzle and it's something
That's great.
is very useful. I think part of the issue is also that many of the teachers may not even be aware of these things.
Yeah.
Two things that have emerged so far after listening to all of you is, one is that the textbooks themselves need to change. And maybe within the textbooks, and also I suppose the training for the teachers needs to be revamped quite a bit, and maybe in-service training as well, because there are obviously teachers who are in the system who are not aware of all of these things. So it's a big task ahead. That's certainly the case. Anything else that anyone would like to add? Otherwise, we will move on to Siddharaj.
Hi, hello.
Hi. Siddharaj is going to talk about e-handbook.
So
teachers.
Yeah, it's coming from the same point of, like what the previous speakers have just spoken about. So I think there is a question that has come up.
Yeah, designing interactive, maybe Siddharaj's presentation may answer your query, Venkatesh.
So actually, like, he's the reason I am presenting here today. He encouraged me to participate in this, Venkatesh sir. I want to thank Venkatesh and Aloka for, encouraging me to participate. So what happened was, like, 2 months back, the Department of Education looked at the NAS scores of Goa, and they realized that Goa has underperformed according to the, when compared to the national average. And that's when I was told about this and I started researching. It's just a 2-month research with some focus group discussions with 10 teachers of middle school in Goa that led me to, think about this idea. And I'm just presenting this idea to get a critical, so that all of you can critique it and maybe suggest ways of improving or, challenging this idea. So I'm Siddharaj. I've been teaching mathematics and science for middle school students outside of the system, that is through after school programs. I've done my fellowship with Teach for India as well, where I taught in the municipal school for 2 years in Pune. So if you look at the National Achievement Survey of Goa, you can see that Goa has performed at every level, right? But if you can see a very high dip in terms of its comparison with the national average at class 5 and class 8, the gap is much bigger, right? So that is why I'm going to focus on these three classes. So if you look at what happened during the COVID-19 pandemic, is that we reported a drop of 4 to 6% in math achievements from the 2017 survey, NAS report. Teachers, but the good thing that happened, like through interactions with teachers, those teachers who were forced to adopt e-learning platforms during the pandemic, and teachers have reported that they use internet to discover resources. But as you know, that the resources online can be, like, first of all, it's not well curated. You can just get any result, and teachers have to use it at their own peril without any sort of suggestions from the system or from a third person. So teachers go on the internet today, just Google for something, they get the first resource they get, they just maybe interact with that resource and maybe try to use it in their classroom. So the data that we have of teachers, this is collected through Google Forms that were sent out to every school in Goa. We have about 1,073 middle and high school math teachers. If you look at the number of the qualification of teachers, 60% of them are B.Ed. That means around 73% of them are graduates, but there are only 30% who are math graduates, right? Only about 30% of people have math education as their highest subject of qualification. I've actually, okay, just one sec. I don't know how to go back. Wait, just give me one sec. Think. Go back. So, yeah. So there are only about 30% who have taken math as the subject of highest qualification. And the curriculum that is followed by Goa board is NCERT curriculum, and we use the textbooks directly. We use the NCERT textbooks in our classrooms. So if you look at the RTE suggested that there is a need for timely completion of the curriculum, and which has led to a confusion between what curriculum is and what syllabus is in the school. So the messaging that has gone to the teachers is that they need to complete the syllabus no matter what. And given the circumstances, if you look at the CSF report, that is Central Square Foundation report, they have done studies in 5 states of India, and they've come up with a finding that 45% of instructional time is lost to non-teaching duties, absenteeism, and multiple classrooms. And this is a very recent report. And right now, what it suggests is that the teachers have to kind of complete 100% of the syllabus that is there in the textbook in 40% of, like 60% of the time, right? Like the time and curriculum is not aligned. So what happens is a lot of times teachers have to kind of just scrape through and just use practices that are very traditional and just methodical and procedural, and not deep diving into particular concepts that might lead to increased interest in mathematics for every child. So the methodology that's followed in the classrooms is typically, if you enter a middle school classroom, you will see a teacher just pick up a textbook, and let's say they have to teach equivalent fractions or addition of fractions. They will tell what is to be done when the denominator is, let's say, not common. When the denominator is common, do this. When the denominator is not common, do this. There is very little emphasis on why you do it, and that makes us realize that there is lack of conceptual understanding that is existing. And I think previous speakers have spoken about that as well. also the teachers and students start perceiving these mathematical concepts as disjoint ideas. So you have these chapters, the mathematical concepts are siloed into different chapters, and these chapters are looked at as disjoint mathematical concepts having no correlation to each other, and which leads to a 12-year-old feeling that math is something that uh, they cannot really comprehend the logic behind mathematics. That leads to this idea that this math is like a monster that they need to tackle. And if I went to a school the other government college the other day, and I asked the principal like how many people have enrolled for BSc mathematics, and this is a college which has around 2000 students, and they said there were just 6 students who had opted for BSc mathematics. So what is happening is the lack of interest that is there in childhood continues, and people get scared of math, and then they don't end up taking BSc, and it becomes a vicious circle where you don't really have math graduates coming out of the system. So it's a long haul to change this, but we have to start somewhere. So if you look at these chapters, like a lot of chapters, this is class 6, class 7, class 8 content of NCERT. This is the front page. A lot of chapters that have it's a spiral model where you have one the certain skills of 6th standard are carried forward in 7th standard and 8th standard and so on. So there is a mapping that is possible where you can have a concept map that leads you from the start to like let's say you start with the number system and the place value and all that, and then why you need fractions, you link it to that. And maybe for example, I'll take you through an example where like there is a model example that I've done, and this is just the start of the exercise. So what we did was we went through all the syllabus of mathematics from 5th standard to 8th standard, because in Goa we start middle school at 5th standard. So we categorize them into different broad areas of mathematics, and under each of these folders we have kind of noted down different sub skill sets that are taught till 8th standard. And this is what we came up with for number system. For example, I've just taken this as an example. We've done it for all the other chapters as well. And under factors and multiples, what does the teacher need to know, or teacher must be able to do inside the classrooms? So I've taken the example of this HCF and LCM as a concept, and we've just listed down what all things the teacher needs to be able to do inside the classroom. So under each of these objectives, we want to have this format of teacher handbook where the teachers and I have come up with this on our own, and we want you to kind of critique this and make it better for us. So right now the things that we are looking at is a concept map, teaching methodology and pedagogy, like different techniques that are laid down inside the workbook, e-workbook. I'll show you I'll demo the example. And if you go through it, like videos of exemplar lessons, simplified techniques, real life use of the concept. If there are videos out there or resources out there, some teacher in the US has used it, or some teacher somewhere in a remote part of India has used it and have put it out on the internet, we can make it available for everyone to watch and reuse inside the classrooms. Also, like what are the higher order thinking skills that you can impart through these different objectives. Also, oral checks for understanding. So this comes from right now what happens is the question that is asked most often inside a classroom is, have you understood? That's not a very good gauge of understanding whether the kid has understood or not, because every child would be like, yes, I have understood. And then you give them a test and you realize they will, and they're not really lying, they just want to get rid of mathematics as soon as possible. So what kind of questions could be asked in order to check whether the child has understood or not? So I've just focused on the concept map bit. So for example, if a teacher needs to teach lowest common multiple, right now what happens is teacher comes inside the classroom and just starts with the method, right? Without kind of emphasizing the the logical consequence of what multiplication is or what tables are, and without connecting that knowledge to previous knowledge, teacher just starts with the prime factorization method and just goes ahead, and lowest common multiple then becomes just a siloed topic. And if you look at it, this lowest common multiple is used further in other skills that are required in higher classes, and the same thing happens. You have to just use it because the book says so and not because there is a logical consequence. I'll just go through the can you see my screen right now? Sir? Can you see the screen? The concept map?
Yes, we can see.
Yeah. Okay. So we've just listed down, this is just a model thing that teachers did. So what are the prerequisites for learning lowest common multiples? And what is its relation with other topics? What are the next concepts that could be taught, right? So then later on, you can link them to the other page as well here. So I've just listed down like pedagogical techniques here. Okay. So for example, like how do you introduce it to the classroom? So there is a video that is up here, and then there's a description of what this video is all about, so that teachers have a central resource that they can go to just before entering the classroom. The previous day they go through this. It's just a 10-minute video that they need to see, so that they try and apply it. Then there are concrete methods that people have used using these blocks. These resources are available in plenty, but they've not reached the teachers as yet. So this ebook is a way of making sure that that content reaches the teachers. And there's a huge task at hand of curating the content and trying to get expert opinion on the same. For example, in this one, the teacher has kind of used 4 different methods to find lowest common multiple. This could be used in an activity where students are asked to analyze why it works in different cases, right? So you can also have higher order thinking skills that could be like that. These methods could be implemented inside classrooms by teachers after going through the activity. Yeah, so
just have to wrap up soon.
Yeah, I'm done almost. So these are some simulations that are available out there where you can, this PHET Colorado and these simulations are basically games that you can use, the teachers can use, and the students can use as well at home. So basically, this ebook is trying to get teachers of the already existing resources out there, giving them a better view into like into what all is available out there. Like as you said, there are a lot of things that teachers don't know today. So
so Ruchi and Vinay are asking, is it open educational resource?
We would want it to be. This is just right now in the ideation phase, and we would want as many people as we can to get on board and try to brainstorm and come up with.
So Siddharth, have you thought about having sort of focused meeting groups or bringing in teachers from not just Goa, maybe outside also?
Yeah, we have not done that yet because the Goa government is right now planning a scheme for math teaching inside. So nothing is official as of now. So we are doing it in our individual capacity at the moment. So we have had visits inside Goan classrooms, and we are discussing with teachers, right? Like we have like 2-hour sessions, just understanding what their issues are at the moment. And we would love to get any support, like anywhere from any part of the world, if people are, just understanding what can be done better, right?
Right.
Yeah.
I mean, so also what you've already done in some ways, it could be shared. I mean, maybe informally right now with the idea that it is mainly for feedback. And so people working in this kind of area, for example, Ruchi is asking about, do you have videos which actually help in conceptual understanding rather than procedural things? So in a way, these kinds of interactions, if they happen, and now you can do it remotely. You don't
Yeah,
even.
so there are
physically
in certain level, lower level skills, there are videos which are available with conceptual understanding. When it comes to some like the higher level skills, maybe not, right? Because what has happened in India is after a point, education becomes like it's all driven towards competitive examination, which means just getting the method done, right?
Yeah.
So that's how the content has kind of proliferated on the internet. So that's the task. We need to recognize, like identify those things which are conceptual and deliver it to the teachers, right? Like directly somehow.
Also, will it be made available to students as well, or only teachers?
So at this point, I'm looking at it as a resource for teachers, but we could have a parallel resource for students because some of the content that we have come across is mainly for teachers. Like there are researchers who have suggested ways of implementing certain activities inside classrooms. And what I showed you was just the videos, but there are also some blog posts and which are more, what do you say, nuanced, and you need more interaction with it. You need to read, and that requires a person who is more aware. So
Right.
for a teacher who is, we need to make it interesting for the teachers to first of all watch it. We make this and then teacher doesn't watch it, then
True.
it's all
Yeah, Levin seems to have a
the
question.
exercise would go waste, right?
Yeah,
So that's why I'm
Sidraj,
asking for suggestions here.
I have a question, Sidraj.
Yeah.
Yes, coming to this e-handbook, we already worked, I don't call it as handbook, but the workbooks. We already made the workbooks for students on our own for all topics. And we have seen that we have included all inclusive learning in that, like going through the problem solving, applying the concepts in real life, connecting to the TOK concepts, discursive. So there are many things we have done for all topics of the syllabus. And that's been very helpful where students really learn through, apart from textbooks. And even the previous session, people are talking about problem solving through books. So in the IB curriculum, we don't believe only in books, because the purpose of learning is not from the books, but for the world, for the life, to resolve the issues around us. So therefore, the learning should go very beyond what is existing in the syllabus, is what we believe very strongly in. And therefore, we designed some topics, and then in terms of IB curriculum, because every curriculum has its own demands. So aligned with the IB curriculum, we have made the workbooks, and just wanted to share with you that.
Are they available in public domain, or what is it?
I just put that in LinkedIn. It's around 250 pages of the workbook, and we're not just doing any marketing or publicity of it, but just trying to help the students to understand the IB curriculum and what are the key essential things which connects to that in the IB. We have done that. Yeah, it's in the process.
If you could just share your contact with me on the chat. Whoever wants to maybe connect further, please send your contact, and I'll connect with you.
Because when you refer to, say, for example, the topic called LCM.
I'll have to call this to a halt just now because we have one more presenter right now. After that, we'll come back. Sorry about this, Siddharajan.
No, it's fine. Lenin, please drop a message.
Yes, sure.
So now we have Shahnaz Saifi, who's going to speak about study of impact of manipulatives in classroom teaching of mathematics at the primary school level. Yeah, Shahnaz.
Yes, my PPT is visible?
Yes, we can see it.
Yes, okay. At first, I would like to introduce myself. My name is Shahnaz and I'm a research scholar in Jamia Millia Islamia. Am I audible, ma'am?
Yes, you are audible, Shahnaz.
Yeah, okay. So, topic of my presentation today is study of impact of manipulatives in the classroom teaching of mathematics at So considering the time allotted, I would like to sum up a few of my slides. Like, this is a very famous saying, and also the understanding and conceptual understanding, we are already talking about it since morning. So when we talk about students, there is no debate that we all agree that if they are engaged in doing something while learning something, the results are better as compared to other methods when they are only taught or they are being presented something. But when it comes to understanding, understanding of a concept in isolation is not supported in the long run, but how the various concepts are interrelated, how they can apply the learning in the classroom of the classroom environment in the daily life, as well as how they are able to relate this in their daily life. So when we talk about the understanding, it's not that they should be able just to follow the method they have been taught, but now we also focus on many skills. Few I have listed over the slide. So now the question arises, or a practice or a point towards which we all are focusing, that how to introduce or a concept so that child will understand it side by side. He is able to grasp some skills, like how to work in a team, how to collaborate, how to enjoy learning, and many more. So for this purpose, the topic of my research was to inculcate the use of manipulative in the teaching. I have listed few reasons why manipulative is one of the useful material to ensure understanding side by side, ensuring the various skills that I have just shown. Like, they are the concrete representation, it involves multiple senses. Definitely when they are having something in their hand, they will enjoy it. But if they are provided such experiences under the guidance of teacher, definitely it will boost their confidence and they will learn independently in the guidance of under the guidance of teacher. So for this purpose, I conducted a small research. It was a post-test only experimental control group design. The data collected was primary, and the primary data was analyzed quantitatively. Also, the process of incorporating manipulatives in the classroom at primary level was also observed. The objective of the study, at first only 3 concepts were used. Were used, and those were place value, addition and subtraction, and money. Population, the population was class 2 students of South Delhi, and the sample size considered 36 students. Those were divided. Those were in the 2 groups. The tools used were the concrete manipulatives, activity sheets, as the teaching was done incorporating activities, and after the experiment, achievement test, which was administered, was developed by the researcher, including 30 items. The focus was given by giving 10 items on each topic. This is a glimpse how the teaching process went. The first thing, it was a very short-term experiment. It lasted for 4 days only. It was conducted towards the end of a session. The concept were already taught to the students formally, and the experiment was done to know the effect of manipulatives or incorporating activities in the classroom from the viewpoint of teacher and classroom environment. It was day 1 when place value was taught. The manipulative use were blocks and some place value cards. The explanation was given to them. Few examples were given over the blackboard. Then demonstration was done, and after a break, activity was conducted. On day 2, addition and subtraction was taught with few activities, and the same procedure was followed. Before the break, they were taught in the classroom in general manner, and after the break, activity was conducted. And on day 3 also, the play money was used, and after the break, the activity was conducted. In all these 3 days, the teaching started with a few questions, demonstrations, and multiple examples how the manipulatives can be used. Basically, the manipulatives were used for the representation purposes, and activities were conducted in the group of 3 and 4, where each group was provided with a activity sheet in which they were asked to write their responses, and the responses were gathered after the activity done. On day 4, post test was administered. It was a 30-item post test, where I already told 10 items were selected for each topic. The analysis of data was done under three sections. It was a group-wise comparison, how the achievement of control group differs from experimental group. Then concept-wise comparison, how 3 different concepts affected the learning, and then the classroom observation, that how incorporating manipulatives in the classroom affected various related aspects. So this is the control group versus experimental group. As we can see, in the experimental group, 5 students scored full marks, and mostly scored more than 20 marks as compared to control group. When we talk about the concept-wise comparison, there were 18 students in a group and 10 questions on one concept. So out of 180, it was observed that experimental group, the students in experimental group responded more when it comes to provide correct responses. Also, money was the fully enjoyed concept when it comes to compare these 3 concepts. When it is about the classroom observation, students were working in a group, so definitely an eye was required so that they will not divert from the path of learning. But they were really enjoying, because from the routine task, they were given something to play with and to learn with. So they were heard saying, "Ma'am, ये तो बिल्कुल असली जैसे लग रहे हैं. क्या इनसे भी हम बाजार से सामान ला सकते हैं?" These 2 lines, these 2 sentences were related to the money. When play money was introduced to them, they were very happy. They have seen it, but they have not used it in the classroom or in teaching. When they were making and they were asked to prepare their answer and show it to me, so while making, they were like, "बड़ा मजा आ रहा है, मेरा बन गया." Once they have completed their activity sheet, they wanted to submit it at first. Now the conclusion. This is not for the first time like any activity or playway method that has been used in the classroom, but still incorporating such activities definitely aids to the learning of a child, but it has many things to focus on. When we say that manipulatives are introduced in the class, there is no debate. It has made it classroom child center. It supports development of motor skills. When money was presented, play money was presented in front of them, they related their many daily life experiences related to money. They were excited, and they share their ideas related to money and how they use money in their daily life. But at the same time, it was difficult and it required a proper management from the teacher side to ensure classroom management, so that there should not be chaos. Also, mere taking manipulatives or any learning material in the classroom is not done, but proper designing of activities is required. It is a planned activity. It evolves time from the teacher's part. Also, if manipulatives are not well fully related with the concept, there are chances that child might end up only playing with them without any learning. So this is it. And now I would like to entertain any question and suggestions.
Thank you, Shahnaz. So if people would like to ask questions, or I definitely wish that I had been taught like this. So, I mean, during my time, I think classrooms were, maths classrooms at least, were extremely traditional. So we didn't get to learn through fun activities or anything of that sort. So, anyone who has any comments or suggestions? So Shahnaz, maybe you can stop sharing your screen, and then
Okay.
So our eighth speaker would have been Arezo Kayumi, and she was going to speak on the difficulties of learning early algebra amongst grade 9 students. But as Ruchi mentioned, she's from Afghanistan, and in fact, from her abstract, I remember that she'd done case study related to learning in Afghan schools, if I remember correctly. But she's somehow not been able to join. So we'll be sorry to have missed her presentation, because it would have brought in so many elements. And one of the things is, whether this issue of difficulty in learning algebra transcends countries. I'm sure it does. But whether there is any cultural specificity which enters into some specific way in which difficulties are faced would have been interesting to see. But we've had a very wonderful 2 hours almost today, of listening to such interesting. I mean, my only wish is that I hope much of this actually reaches teachers who are, involved in their day-to-day teaching. And Ruchi's raised a hand. Ruchi, yeah, if you
just wanted to add a few lines about Arezo's research itself. And so this research was done in the earlier regime in Afghanistan, and where it was possible for women to, go unaccompanied by men and do research. In fact, she was my temp student. It was for a master's student. And the Swedish Committee of Afghanistan is an institute which has been working for several years, and they had sent around 40 teacher educators from Afghanistan to TIS to improve their understanding and skills about mathematics education, and they were hoping to get employed as teacher educators or teachers in schools. But unfortunately, with the change of the regime, all the female students who had come now have to sit at home, and there is almost very little chances of employment or of females getting an opportunity for education. The schools above 6th standard are closed for girls, and even for schools below 6th standard for primary level, initially the girls and boys were sitting together. Now they have been separated, and only women can teach them, and no women are employed. So in a way, it is like sounding an ultimatum that girls will not be educated at all, and it's a very sad development. But we all need to know about it, and we all need to think, how the gender diversity is getting affected in terms of education, in terms of employment, and what a crisis it is. That's all.
Thanks, Ruchi. Yeah, it's a tough situation. Terrible to hear, but so tough for the people who have to undergo it, certainly. I think Asif Andrabi had raised their hand. Do you want to say something, Asif? Okay. Shubhangi, why don't you unmute yourself and say what you put in the discussion?
Yes.
Shubhangi?
Yeah. Can you hear me?
Yeah, we can hear you. You can switch on your video too if you wish.
Maybe there will be some connection issues. So is it okay if I?
Yeah, sure.
What I feel sometimes when we do some fun activity or hands-on learning, after that kids they learn, they remember the fun part of it, the fun element of it, or sometimes the gamification, they feel that, oh, winning or losing means they'll learn through it, that is okay. But what I feel that after that we should connect it with the routine mathematical procedures what we are doing. For example, maybe long division method or finding LCM and HCF. We use these activities for HCF, taking beats and all, then take out what is the maximum factors. But that connection or that discussion, sometimes we missed on that, maybe because of the time constraint. So, and that is something really very important, and that kids should learn. They should understand these two are not separate things. But whatever we are doing, the division method for finding out the HCF is derived from this, or this is what is the maths behind that to find out the HCF, especially for that long division method. I always feel that why it is used. I mean, what's the connection, how conceptually it is connected with the maths. And that's the reason I thought of mentioning that here.
Yeah. Shubhangi, in fact, we teach the long division method in theory. I mean, the actual proof that at the end of it you come to the HCF. And when I do it in the classroom with my undergraduates, I remind them that, look, this is what you did in school. And this is why it actually does work. But I mean, I guess what is definitely important is that at every level of school, the children not only get the conceptual understanding, but they're also trained at the same time to apply those concepts and to apply and learn also the procedures that are required. I mean, I think we've had earlier, at least in the generation when I studied, a lot of emphasis was on the procedure. We had to learn all the multiplication tables really well and so on and so forth. But what it also did help was that our mental arithmetic or capability of doing arithmetic was quite good, which then helped when we were learning higher and better things. I mean, like fractions or algebra or any of that sort. I mean, this is my personal opinion. I'm not sure whether it is valid or not, but I feel that there's a period when we moved to, thinking of all this only as rote learning and therefore wanting to rid the system of it. And I think, I mean, when I look back at when my daughter was studying in school, I feel that conceptual understanding has to be there. There's no two ways about it. But along with it, I'm not entirely sure we should lose these skills and just move to, using computational devices. Some of these things help in sort of, being able to work with things faster, certainly. So, yeah, before I forget, we are almost at the end of the time. I will allow 5 minutes more for discussion, but those of you who are part of the MTA, there is the general body meeting at 12:30 So please join in and let us all come together to make MTA more effective. And then from 3 to 4:30, we have a panel discussion. And that's really looking at, in the last few years, we've had the national education policy. We have so many different things that are emerging from at the policy level. And so that's a panel which is going to look at how it affects us, particularly already at the higher education level, the undergraduate system is undergoing an overhaul. And of course, that affects everybody because our teachers are essentially coming from the pool of undergraduates. So it's something that I think everybody will be invested in. So please do come and join us and do volunteer for the cultural program, which we are going to have at the end of this conference. I think there was a link shared yesterday, but please, if you want to spend 5 minutes singing or something else that you're good at, so please do volunteer to be part of the cultural program. And now for the next 5 minutes, the floor is open. Anyone who wants to say something can do so, and then we'll stop because we have the GBM after this. So anyone who wants to unmute and speak.
Yes, Dr. Geetha, the last discussion was quite interesting. So I thought I'd be just going through with how the balance can be done on the flow of math. Thanks for Shubhangi to bring this at the right moment, because we cannot expect things to be conceptual every day. We cannot expect things to be on taking a manipulative and then explaining through deep concepts. You cannot have math lab every day with the sessions. It's a balance. I agree with you and even Shubhangi that, there are some skills which you need to identify in all means. Problem solving skills, of course, when they do a lot of problems, and then algebraic approach and algebraic skills, and then going through experiential learning where self-regulatory learning skills are enhanced. So it is all something which we need to include in a balanced manner. And it's very essential. It's not that we just do the manipulative and just students don't have any opportunity to reflect. I do the activity for the day. And what is the point when I don't reflect? And what is the point when students do not know what is the purpose of learning this activity? In what way it is helping me? Trigonometry, I'm trying to find the heights and distances using sine theta, cos theta, and tan theta. So the whole real life application should make them understand in a sense that this is where the concept is used. And this is what I'm learning in my class. This is what I'm solving in problems. So that connections should be made in the flow. It's very essential to make the connections when students know the purpose of learning, and that is where they enjoy. And when they enjoy, they take you in as an inspiration. That is how you become a great teacher, not a good teacher. So that is very essential in the process. So when students want to have the impact in the learning and they want to make you a role model, these are all something we need to balance in a flow right from day one to day end of the academic year. So that's really essential. So thanks for bringing this out, because this is something we are researching on more further. And that's a very, very essential factor in the plan or organizing part we make to all these discussions. Just I want to share on that. Over to you.
Anyone else who might want to say something? Otherwise, I suppose let's all give a big hand to all the presenters. And thank you very much for this wonderful session. Please join us for the other events in MTA. And I'm going to close this session now, unfortunately, because there are things coming up from 12:30 onwards. And thank you all for being here. Thank you very much.